Problem number 33 is the next one we'll take a look at, and it's a little bit different than the one I had done yesterday, problem number 34, and hopefully you realize why it's different pretty quickly. But what we want to do is we want to find the value of a and the value of b that make this function continuous. So we don't want there to be a jump when we transition from this piece of the graph to this piece of the graph to this piece of the graph. What I'm going to do is I'm going to start with the piece of the function that we know all of, this 2 sine of x over x. And that's going to be the definition for this function as long as x is less than 0. What I want to do is I want to figure out where the open circle is, where this piece of the function leaves off. Now, a couple clips ago when we were doing some problems from earlier in section 1.4, to find the location of an open circle, I plugged this value in place of the x's. I evaluated and I got my answer. You should hopefully realize that's an issue here, because if we put a 0 there, sine of 0 is 0. If we put a 0 there, we have 0 over 0. That's indeterminate. That's an issue. So what I'm going to do is I'm going to do this actually graphically. So I already have this function graphed on my calculator here. I'm not really going to focus on the graph so much as focus on the table. I want to see what value my function, and for the function at 33, it's really just this top piece that I have graphed right now. But I want to see what value this function takes on when x is just beneath 0. So basically what I'm doing is I'm checking the limit as x approaches 0 from the smaller side on the graph of f of x, which corresponds to the limit as x approaches 0 from the smaller side of 2 sine of x over x. I'm going to do this graphically, or numerically rather, on the calculator. So I'm going to go to my table settings on the calculator, and I'm going to start my table at, where did I want to know? 0, right? Yeah, I want to start my table at 0. I want to see what's going on just on the underside of 0. I'm going to make the jump in my table 1/1000th. I'm just going to go take a look at the table. I have an error at 0, but I see that on either side of 0, I have function values that are 2. And hopefully you're pretty convinced that we can then say that the limit as x approaches 0 on this function is going to end up being equal to 2. From the smaller side or from the larger side. When I had the calculator up, you probably saw 2's on both sides of 0. But on this graph, when we get close to 0, we're going to be approaching a y-coordinate of 2. What that means is that this top piece of the graph is going to have an open circle at an x-coordinate of 0 and a y-coordinate of 2. We need to make sure that this next portion of the graph, which is just a constant defined for the singular x value of 0, we need to make sure that this point that we place on the graph fills the open circle created by where this piece left off. So the open circle's at 0, 2. We need a to be 2 so that we have a closed circle at 0, 2. So a is going to have to be 2 based on that discussion there. We would also want the open circle where this last piece of the function picks up to be in the exact same location of this open circle, and then the closed circle that we just talked about. So if a is 2, we definitely do get a closed circle at 0, 2. I need my second open circle, so maybe I'll call this open circle number 1. I need my second open circle to be in the same location, 0, 2. I need to force this to happen. I need to pick the appropriate value of b that makes this last piece begin with an open circle at 0, 2. So I'm going to copy b cosine of x down below here. I know that my open circle has to be at 0, 2. So the x-coordinate of it is 0. The y-coordinate of it is 2. So I'm going to make this equal that y-coordinate, and I need to be able to find this value of b. If you figure out what the cosine of 0 is with a little bit of help from the unit circle, here's the angle 0, The x-coordinate there corresponds to cosine of that angle, and the x-coordinate right here on the unit circle is 1. So this says b times 1 equals 2, or b equals 2. So this was a little different than problem number 34, which I did yesterday. Little easier, maybe a little quicker. You had some nicer values pop up here, but a little different because of this that happened to us right off the bat. If you have any questions on this, feel free to stop in and ask. Give number 35 a try as well as number 37 a try.